Hi and welcome to Unit 2, Topic 3, Video 10. And it's time for us to talk about inverses and determinants of n by n matrices. Notice a square matrix, really important that we recognise still that inverses and determinants only exist in square matrices. So the question I want to ask you is, can you calculate the inverse of the matrix 1, 2, 1, 0, and 1, negative 2, 0, 1, 1? And the answer is yes, there's a method. It's fun, it's great fun to generalise, it does take a while, and it's actually quite helpful for your work on vectors in Unit 3. But the other answer is, no, we don't need to, it's not in the syllabus. So the syllabus clearly states that you need to be able to calculate by hand for 2 by 2, but you are allowed to use technology for n by n, or where n is greater than or equal to 3. So I'm going to show you how to use the technology now. And then we have an example 7 we're going to play with. So let's jump along to the calculator. I'll be using the Casio. This is the non-CAS Casio that we're allowed to use in this example. And I'll try and make sure that you can see the full thing here. So let's flick across to the Casio now. So there's my calculator. I'm just going to make it fit into the screen we're working with. So I was missing a couple of numbers at the bottom, but that's okay. And I'm going to go into the Run Matrix screen. I'm a little bit rusty with this, but I'll show you how I explore it. So you've got all this stuff here, and I'm going to go to my options, and in my options, I've got my matrices and vectors. I've got things I can do there. You'll see here's a determinant button, and you'll see there's other options, dimension, identity. I can find reference points in that matrix. It's worth having a play around with those. Later on, we'll need dot products and cross products, perhaps for vectors. You've done some dot products already, so you've probably seen these, and it's worth having a play around. But what I'm going to do is, if I click on that, that's my naming convention for matrices. But to use that, I need to have actually given a matrix a definition, which I haven't done. So I've got a couple of ways of doing that. So I shouldn't have done that. Clear that. So the first is that if I exit out of here, I've got a matrix vector section there, and I can actually define matrices. And this is a really good way to do it in exams because you might need them for more than one situation. So I'm going to do it here for the question that we've got. So you might recall that the question asks us to find the inverse and determinant to solve for a certain matrix multiplication. I've got the two matrices here. So they're going to be a 3 by 3 matrix. Oops, 3 there, and execute, and then 3 there, and execute, and it will give you my matrix here, and now I can enter those numbers in. So this matrix is 1, this is the first one, 2, 1, 0, 1, negative 2, and then 0, 1, 1. Now, I'm going to keep on going. I can change these values, by the way, add rows, add columns, edit the matrix. But now I'll just go execute, and I'll save as matrix A 3 by 3. Now, I do need matrix B as well, because I've got two matrices in this situation. So I'm just going to set this up quickly. 3 there. Matrix B is, of course, 4, negative 3, 7, 1, negative 3, 3. 1, 0, 3, and I'll go execute on that, and then I'll click exit, and it takes me back. You can see I've got them both defined. Now what I'm going to do is just quickly go back to here. This is the question. So go through now, get your calculator out and define those two matrices. Rewind the video if you need to see how I did it. Okay, so welcome back. Now we're dealing with these. Now let's have a play around with some of our operations first of all. That's not what I'm meant to do. If I go back to the calculator here, if I exit from this section, now, and some of this will be maths, that's a little bit of a shortcut, but let's go into options, matrix vector. If I want to call a matrix, I need to use this matrix naming convention. So I go matrix and then alpha A, and it will actually feed me back that matrix. That's the one I defined earlier. If you can't be bothered going into here, it's also above the 2 on your calculator. So you can do shift matrix. So I can go shift 2, and then I can go alpha B, and it'll give me the second matrix I defined. Now I can also do this. So I can click F3, determinant, And then I want to do determinant of shift matrix and then alpha A and execute. And that actually gives me the determinant of matrix A, which is going to be important a little bit later on. Now I can also work out the inverse of matrix A if I'd like to, and this will also be important. So to find the inverse, just scoot across here. Oh, sorry, no, to find the inverse is easier than this. I just go, well, I can click on matrix or do shift 2, matrix A, so alpha A, and then I just do to the power of that one there, and I'll put -1 in there. Execute, and it gives me the inverse. Now you'll notice here with this inverse, if I just scoot up, that it's got a whole lot of denominators that are 3's. And our determinant was 3. So you can see that 1 over the determinant of A popping in there again. And it's true, and you can have a read of that if you want to. Now I've got some information there, and I probably won't come back to the calculator screen. So what I'm going to do is I'm just going to go up and get a copy of our solution here. I'm just going to take a little snipping of it because we're going to need it. Although we probably will come back to the matrix again because I can't be bothered doing the modification in this video. So let's have a look at what we can do with it. So we've got a little recall section there. Recall that if AX equals B, then A inverse A, X equals A inverse B, IX equals A inverse B, and then X equals A inverse B. So what's going to happen here is I could define this. It's really a bit of a pain doing them with the full matrices, but I would show this. This stuff is an important part of the working to show. So I would still demonstrate it, but then once I've demonstrated it, after calling this one A and this one B to do so, I get this. X is equal to A inverse times by 4, -3, 7, 1, -3, 3, 1, 0, 3. And of course, our A inverse was this guy here. If I just right click here and paste, that's my calculation for A inverse. So instead of mucking around now, it would just be times by this. I'm going to show you how we can finish this question in the calculator because remember, we can rely on technology for this. So the full question on the calculator, or you can do it in parts because I've got my answer here, but the full question now would be to do matrix alpha A to the power of -1 and then multiply that by matrix, and remember we define the other one as B, alpha B, and this will give us our X value, which is interesting because that's turned out to be all whole numbers, but that's often how we set up our questions, as you'll remember. So it's all whole numbers, and it's 2, -2, 1. I'll just write this down. We get X is equal to 2, -2, 1. And just going back to here, 1, -1, 3, and then 0, 1, 0. 1, -1, 3, and 0, 1, 0. So there's my final result in the matrix for X. And it all comes from this form, matrix A inverse times by matrix B, and making sure that I have multiplied on the right sides, because if I go back to my OneNote here, you'll see that I had to do left-hand side multiplication because this value here was left-hand side multiplied by X. Okay, so that is our section on inverses and determinants of n by n matrices, but just practice using the technology for that. And I would definitely be making sure now that we've finished this video that you just did everything I did on your calculator. All the best.